Hello everyone. So today we are going to work on this runtime generated landscape. So today we are going to implement the landscape generation function in C++. Earlier we had used blueprints, and last time we started converting the blueprint class we had written into C++, and now I have fully written now we are going to fully write the landscape generation code in C++ instead of blueprints. So this is the final result after writing it in C++. Not the final result of the series, but the first cut of the landscape generated using the first version of the terrain generation function we are going to write today. So the reason that we are going to turn this into C++ is because I hope that I will be able to get better performance, and also I hope to implement multi-threading so that we can keep generating the landscape infinitely as the player moves around the world without interrupting the main game thread. So that's why we are moving into C++ direction with this project. And before we get started, I'd like to remind you that, as always, you can download the project files of the projects that I'm working on in my channel in the Patreon page. So not just this project, you can download any project. There are over thousands of projects to the date, and once you become a member, you can download any of them without a limit. So feel free to check it out. That would help me to continue what I do with this channel. And back to the tutorial. Okay, so this is what we have as of the moment. So last time we set up this C++ class, which is this one. So now we are going to implement this generate terrain function in C++. This function we have already written in using blueprints. So now we are going to convert this into C++, hoping that we can get better performance, and also in future we can utilize some multi-threading so that hopefully we can generate terrain without interrupting the main game thread. So right, let's get started. So first, let's go back and take a look at the terrain generate terrain function blueprints. So here, first thing we do is calculate section offset. So here what we do is, for each section of the mesh we create, we have to add some offset to all the locations, because we are implementing the terrain as tiles. So each tile we have an offset. So we have already discussed about this and developed the logic. So let me just copy this function, this part, calculate section offset, into C++. So we already have the offset variable here. Oh, one more thing here, let me remove this edit anywhere part for the, not for material, edit anywhere part for terrain mesh, because we don't have to edit it anywhere, it is automatically created. So actually the offset is a local variable, so we don't have it here. So we can simply define it where it's a vector. So f vector offset, and we can initialize it in this place itself. So new vector, the way we calculate it is section index multiplied by x vertex count minus 1 into cell size. So section for the x component, section index x multiplied by x vertex count minus 1 multiplied by cell size. So x vertex count minus 1 multiplied by cell size. Okay, actually this cell size multiplication is common for both, so that means we don't have to put it inside. Let's define the section y component as well. Section index minus 1 multiplied by y vertex count minus 1, and the whole thing multiplied by cell size. So we forgot about the z component. So okay, so now this is the offset. This whole line, this single line, represent everything that is going on here. Okay, so now that's this part. Then we need two for loops starting with index minus 1 and until y vertex count and then x vertex count. So for, and here we are going to calculate vertices and UVs for. So this should be int 32. I instead of I, I'll use IVY. Stands for vertex y. Okay, and it goes until just less than and equal or equal to y vertex count. So this for loop here starting with minus 1. Okay, and then another for loop for x index IVX until x vertex count is than or equal. Now here we start to add vertices. This is a local variable. Vertices is a vector array. So I'll define one, a vertices array. So T array vector vertices. Also I'll add another f vector vertex. So I'll use this for the calculations, and then add finally after finding out all the members, I can just add this into the vertices. So x is calculated like this. Offset x component plus x index multiplied by cell size, and y is calculated by offset plus y index multiplied by cell size, And for 𝐿 we have a different function, so let me just add x and y. So vertex dot x equals ivx multiplied by cell size. Oh, we don't need a bracket. Plus offset dot x. Okay. Similarly, vertex dot y, ivy multiplied by cell size plus offset dot y. And vertex 𝐿, for now I'll use vertex dot 𝐿 as 0 because I just need to make sure the function is working first, then we can work on the height map. Okay, now that's the vertex, and next is well, actually let's define a placeholder function for this, getHeight bp. So getHeight function name should be getHeight, and this can be, it doesn't have to be a u function, so float getHeight, and what we need to give is input x and input y. So x and y coordinates, that means an f vector 2D. So f vector 2D, so I'll call it a location. It's a location. Okay, so for now it will return this. Okay, and this is the vertex. So after that we need to add these two vertices. Vertices add vertex, right? And the next part is UV. So the way we calculate the UV is we just multiply this x and y is ivx and ivy. So here also first we need to add a vector 2D variable. So for UVs, TRA f vector 2D UVs and a single UV for calculations, f vector 2D UV, right? So the way we calculate is uv.x equals ivx multiply with cell size plus offset. Oh no, that's the vertex. ivx plus x vertex count minus 1 into section index x and multiplied by cell size. So we need a bracket iv x plus another bracket section index x multiplied by x vertex count minus 1 and multiplied by cell size divided by 100. That's what we do here. And for the uv y coordinate, same thing but with y. Right. Alright, now the next step is calculating the triangles. So UV part is done. The next part is triangles. Let me remove this unused stuff. And here we need to do another double for loop starting from 0 this time. So triangles. For triangles also we need this integer array. So here the array and 32 triangles. So for 2 for loops and 32, and this one I'll use itx because not x to y, because it's for triangles, triangle index, something like that. Length is just like before, by vertex count not less than or equal. Another for loop. itx x vertex count. Oh, this is too small for you guys. Okay, so how do we calculate the triangles? X, first element is x index plus y index multiplied by x vertex count plus 2. So triangles, here we don't need a temporary variable, so we can directly add x index, that means itx plus ity multiplied by x vertex count plus 2. Yeah. And the second element is the same thing as before, and to that add x vertex count plus 2. So that means x vertex count plus 2 added twice. So that means we can simplify it. Yeah, like this. And the third element is first one plus simply add a 1. So this add 1. Right. Okay. So this is one triangle. We need the next one. This is actually the second one, same as this, and third one is second one plus 1. Second. Then third one is again third one. So this. Okay, triangles completed. So now we need to get this subset. So if you don't remember, we did this to get rid of the seams in the boundaries of mesh sections. So we discussed about that issue in this video, fixing seams between tiles. So basically, if you don't remember, let me just explain it again briefly. So what we need is to draw this tile, but instead what we are doing is, but if we just use this tile, calculate the vertices and draw this tile, we get a seam in between the first tile and the second tile, because when we calculate the normals, it doesn't have the points after this edge. So because of that, the normal calculation is not correct. So instead what we are doing is, when we want to draw this black square, we calculate vertices for a bigger square and then calculate normals, because now for this inner square we have the correct values. So from this we get this smaller square, the vertices, normals and everything relevant to this smaller square, and use that to render our mesh section, so that we can get correct normals for the points in this, within this black smaller square. So that's the reason that I get this get subset, that I use this get subset function, so that we have correct normals and we can get rid of these seams. Okay, so how do we do this? Again, we need to filter. Before filtering, we need to calculate tangents for mesh, so we can get normals and tangents for that bigger mesh. So here we have this calculate tangent for mesh in C++ as well. Here C++ calculate tangent for mesh. This is the function. So we need to use this header file in order to use that function. So I'll add it here, and then here we need to pass address of vertices, address of triangles, address of U is address of normals. So we need these normals and tangents variables as well in our function. So here normals are also a vector, array f vector normals, and tangents. So the tangent type is array f prop mesh tangent. So this is the data type for tangents. Now we need to, so the next part is calculating subset mesh to prevent seams. Okay, so then calculate normals. So you 𝐒𝐻 mesh library calculate tangents for mesh. So we need to provide vertices and then triangles, and then UVs, and then normals, and then tangents. And that's all. Okay, so now when we call this function, the calculated normals and tangents will be assigned to this given normals and tangents variables, because we are passing this as, here if I go to the definition, passing this as references. Okay, so then we need to filter the subset. So subset vertices and UVs. So just like before, so big normals and big tangents, that is this normals and tangents. So I didn't use the big normal here, but that's it. That's the same thing here. So again, for each vertex, for the vertices we have, we need to iterate. So that means this same two follow-ups. Okay, so now we need so this is this calculation. We have this out normals, out tangents, out. So I didn't define a separate function for this, therefore we need to add a set of different variables with the same types. So let me copy this and paste. I don't think we need this individual variables because we are just filtering. So sub I like the prefix sub because these represent the smaller square that I explained here. So inside the follow-up, if x is larger than -1 and less than x vertex count, and y is the same condition, then only we should add the current element to the out vertices or the sub vertices. So we need this index, and I'll call it vertex index. So the condition is if y is -1 less than ivy, and ivy less than y vertex count, and -1 less than ivx, and ivx less than x vertex count. So if this condition is true, sub vertices add vertices vertex index. So this is how we filter the same thing that we do here, and in the same way we can filter the UV and the normals and the tangents. So sub UVs add UVs vertex index, and sub normals add normals vertex index, and tangent sub tangents add tangents vertex index. Okay, and regardless of the conditions we need to increment vertex index here. Okay, and after that we need this for loop to loop through the triangles and filter them. Actually in this case we are kind of recreating or recalculating, but this is different to the previous case. Earlier it was going from until vertex count, but here from 0, earlier we are going from 0 to vertex count, here we are going from 0 to vertex count plus 2 or minus 2. Oh, we made a mistake here. This also needs to be -1. Yeah, -1, -1. 0 0, and here also -1 -1 for the subset, and then 0 0. Okay, we can copy this, but this time subset triangles from 0 to by vertex count -2, x vertex count -2. And the way we can add is for the triangles IX, IVX in C++ terms, IVX plus IY multiplied by vertex count, X vertex count. So sub triangles add ITX plus ITY multiplied by X vertex count, and the next element, into that add the X vertex count. So and next is the first one +1. And in the next triangle, first index is the second one of first triangle. And the second one is second one +1. And the third one is the third one. Okay. Alright, so triangle subset is now filtered and now created. So now all we have to do is creating the mesh. So create mesh section. So terrain mesh, create mesh section, section index, mesh section index, and then sub vertices, and then sub triangles, subnormals, UVs, sub-UVs, and color. So I don't want to give a color now, so the array f color, so empty color array, and subtangent, and generate collisions row. Okay, and then if we have a material, terrain material, if we have assigned a valid material here, terrain material set not terrain material, terrain mesh, set material index is section index, mesh section index, and material is terrain material. And finally, mesh section index should be incremented so that we can add the next one. Alright, so that's all except this implementation of the height map. Well, we did a lot. Hopefully it will work. Let's compile. Okay, let me save everything just in case it crashes. No, so instead of this generate terrain pp, we can call generate terrain function, which is implemented in C++. Right, play and crashed. Line 77, wait. Oh, here we forgot to add the UV. UVs dot add. UV. That should be the case. Okay. Let me go back here. Reconnect the C++ function. Compile, save, play. Yeah. It's working. Oh, I think we are on an invisible plane. Yeah, actually we have this water plane that I have made it invisible, so that's what we were on. Okay, so yeah, the mesh generation part is working. Now you can see the generated mesh, but as you can see, there is no height data because we didn't work on that part. So let's work on that part in the next episode, and I'll stop this episode at this point. So thanks for watching. As always, updated project files will be available for you to download in the Patreon page. Link would be in the description below, and see you in the next episode. Goodbye.